Hi, I'm Bill Peterson with Faradyne Outdoors, and I'd like to introduce you to our new Helios fletchings from Nockturnal. And what we've got is we've got the world's first lighted vanes, and the way they work is we have a molded slip-on vane system that you'll put a couple of drops of CA glue in there to hold it in place, but it also comes coupled with a lighted knock so that the two of them together ends up with a lighted fletching system. Now, as an engineer, I got to tell you that I'm excited about the fact that we have the world's first lighted fletching, but what I'm really more excited about is the aerodynamic performance improvement of this. If we can zoom into the fletching again, I want to show you some of the features of the geometry of this. What we've got, and I got to tell you, these are prototypes, so they are a little bit beaten up, but we've got 6 fletchings that are actually 3 groups of 2. And you notice that they're a very small profile. If I compare them with a very high quality competitor, being a Blazer vane, which, you know, they're industry standard. I love a Blazer vane myself, but you can see the smaller profile of the Helios. And with those 6 vanes, what we're able to do is we're able to shrink the diameter, and we have a curve out on those vanes. So when we hit it with a crosswind, that crosswind flows up and over that vane, so it's largely unaffected by crosswind at all. The other thing about it, when we put this, we've got a wind tunnel here that will show you, demonstrate this for you, but as it spins, it's going to spin quite a bit faster. Now we all know that you can make an arrow spin faster by putting a greater helix on the arrow, but as you put a greater helix on that flat vane, all you're really doing is putting an air brake on it, and it causes your drop of your arrow to be pretty significant. This is a totally different technology. What we did instead is these little vanes are actually just like an aircraft wing. We create a low pressure region to create the spin without the drag. So we get a greater, much greater, in fact, over 10 times greater spin rate than a traditional vane, but without the drop that we get in a spin or in a traditional vane. So let me show you the wind tunnel. What I'm going to do is I'm going to put a crosswind on the vane system, and I'm also going to send, this is just free floating in here, but I'm going to turn on a fan and send a crosswind on there as well. And people at the ATA have loved this demonstration. I'm going to speed the wind speed across the vanes up to about 200 feet per second. And we've got a tachometer reading on that. And it looks like right now we're reading about 1700 RPM on there with the crosswind speed of a little bit over 10 miles per hour. As we increase the crosswind speed blowing across those vanes, you'll see that the RPM on those vanes is virtually unchanged. What we'll see all the way up to about a 25 mile an hour wind speed, we'll see very, very little change in the RPM. And once we get up to about 25 miles per hour of crosswind, then we have about a 2 to 3% loss of RPM in our vanes. So Nockturnal.com, check them out. Thank you for your attention today, and hope you made it to the ATA yourself. Thanks.